Hi guys. Alright, so we're looking at translations in this video, also known as shifts. And really none of this should be brand new to you. This is stuff we studied earlier in the year when we were talking about other types of functions. So we're looking at transformations, and the first type of transformation that we're looking at is a translation or a shift. And I'm going to use just sine of x as my main function here. Please understand that I could be substituting in cosine of x or tangent of x. Okay, so the first translation here deals with if we were to add a number or subtract a number onto the main function. So picture your sine curve from before. If we were to add a number or subtract a number onto it, what's really happening is we are going to see a vertical shift either up or down. So in the case of adding a number, it really means we have a vertical shift up d units, and if we're subtracting d onto the function, then it's a vertical shift down d. Now keep in mind before that the horizontal axis, or what we call the principal axis, if we were talking about the basic sine curve, it was y equals 0. Well, if we are going to be shifting our entire function up or down d units, what that really means is y equals d will become the new principal, also known as horizontal, axis. Okay, so your y equals d is going to become that new center line that goes through the middle of your graph horizontally. So y equals d, remember we said the principal axis is really the average of the max and the min. Okay, it's 1/2 the max plus the min. So this y equals d would be your new principal axis. Okay, so it could be a negative, it could be a positive. All right, but that number on the end here, so in the case of doing minus d, all right, if we have a minus 3, then y equals -3 would be your new principal axis. Okay, so just be aware of that fact. All right, so we have vertical shifts, okay, referring to up or down. That's where we have a number on the end, all right. Then we also have horizontal shifts. This is where we're looking at on the inside. Notice how we have sine of, in parentheses, x minus c or x plus c. Again, we studied this earlier in the course. This should not be a new concept for you. So the idea of having an x minus c on the inside means we're going to have a horizontal shift to the right, all right, c units. And if we see an x plus c, remember we said it's the opposite of what you would logically think. If it's x plus c on the inside, then you're really going to the left, however many units c is. Now, finally here, it's important to note that these shifts or these translations, they are not going to affect the amplitude or the period. So remember the amplitude, the idea of 1/2 the max minus the min. If we are taking a function and moving it up or down or left or right, that amplitude is not going to change, nor is the period going to change, right? The length of time required to complete a full cycle is not going to be changed if we move the function up or down or left or right. So we're looking at shifts here, both vertical shifts and horizontal shifts. Okay. Alright, so take a moment please and sketch this graph here. Our goal is to write an equation. Now I'm going to have you focus on the keyword an equation, not the equation. So that implies there's more than one possible answer. And make sure you capture these 3 key points here in our graph. Okay, so we have marks going by 3. All right, so we have pi there, and then 3 more marks takes us to 2 pi. If this were in degrees, we would be talking about pi over 3, of course, is 60. This negative pi over 6 would be negative 30, and then this 4 pi over 3 would be 240. Okay, so we're looking to write an equation here. So we can see that clearly this is not the tangent function. So our options are to use sine and cosine. So we're going to do both. All right, you're not expected to do both, but we'll show you both, and then you can pick whichever one you think makes the most sense. So suppose, now first of all, we see that the maximum value and the minimum value go from 1 to -1. Okay, so the amplitude is 1. All right, and so we're looking at either a basic sine or a basic cosine graph here that's been shifted either left or right. So it has not been shifted up or down vertically. Instead, it's been shifted either left or right. So suppose you are in love with cosine and you just are determined to write this as a cosine function. Well, you have to remember that cosine, and write this down, cosine starts at the point 0, 1. Okay? So it has to start up at 1. So in other words, if you are going to use cosine as your function, we need to make this start right here at 0, 1. So normally cosine starts there at 0, 1, and we know that it's going to drop down like that. Well, here is the basic shape of that, okay? But we can see that it has been shifted over to the right from where it normally starts. So because it's been shifted over to the right from where it normally starts, we need an x minus. All right, that minus means we need to shift it to the right. Well, how far has it been shifted to the right? Well, pi over 3. Okay, that's what we see going on right here at this point. So if we want our curve to start there, all right, we would have to shift it over to the right. What's up, buddy? All right, sorry about that. So that's one option. The other option is to write it as a sine function. So if you're set on writing it as a sine function, oh, thank you. I love when my kids interrupt me. Okay, so anyway, what was I saying? Oh, starting it as a sine function. Well, sine starts at the origin, right? 0, 0. So our sine curve, what, sweetie? All right, let's try it again. So sine starts at 0, 0. So the basic sine curve we know starts there and then has to go up and then come down. So it would appear that on our graph here, this would be our starting point, okay, because from there it goes up and then comes down, right, and forms what looks like the sine graph. So this needs to be shifted back over, all right, to the origin, all right, if it's going to be our sine curve. So think about, all right, what has happened from the original sine curve. So from the original sine curve, it's been shifted to the left. So if we want to express a shift to the left, we need an x plus, and then that distance over, which would be a positive pi over 6. Okay, so that is showing our shift to the left, pi over 6 units. Of course, here we see a negative pi over 6 because it's in negative territory. But if we were to start in the origin and then shift to the left, pi over 6, of course, that's where you would end up. All right, so these are your two possible options for writing the equation for this. All right, you don't have to do both. You just got to pick whichever one you like better.